Good morning, students. In the last topic, we discussed the assignment problem. Now, in this lecture, we'll do the simplex method. This is the another method to solve the linear programming problem. Now, we'll take one example. We are taking first the maximization problem. Maximization z is equal to 3x1 plus 2x2 subject to, these are some constraints, x1 plus x2 less than equal to 4, x1 minus x2 is less than equal to 2, and x1 and x2 is greater than equal to 0. Now what is exactly the problem is, this is the problem for the maximization. The question is the line of this. The first, basically this is known as the objective function. These are the two constraints. What basically we need to find in this question is the values of the variable. Now what are the variables in this question? x1 and x2. Now the first condition is we need to know the constraint, is it less than equal to or greater than equal to, but in this question it is less than equal to. So how to make it balanced? So first of all, what are the steps of writing the questions? Number one, you have to write down, since this is a maximization problem, write down the objective function as it is. Now next is, since this is the condition of less than, it means there are two conditions. Number one, the less than condition, and number two, the greater than condition. You have to check first. If there is a less than condition, it means to make it balanced. So to make this equation balanced, what you have to do is you have to add one non-negative variable. You have to add one non-negative variable which is known as slack variable. Only in the condition of less than. But if it is greater than condition, you have to add one artificial variable and subtract one variable which is known as surplus variable. Right? So today we are discussing only the questions having less than constraint. Correct? Now the next is subject to. So the first equation is x1 plus x2 less than equal to 4. Since the condition is less than equal to 4, it means we have to add one slack variable which we are naming as s1 equal to 4. In the another equation, x1 minus x2 plus s2 equal to 2. So in the first equation, we add one variable which is known as s1. In the another equation, to make it equal, to make it balanced, we are adding the another variable as s2. Now, if you are adding the variable in this given equation, you have to add these two slack variables to the objective function as well. Now, how to solve this question? You have to create first the table. Now step number 1, you have to create the table. This is by default. You have to make it in every question. The first is basic variable, second is cost of basic variable, the third is xb, which is known as the right hand side of the equation, and write down all the variables which are using in this question, like x1, x2, s1, s2, and the last column is minimum ratio. Right? Now what is basic variable? What is the cost of basic variable? What is xb? What is x1, x2, s1 and s2? One more thing is we have to write down the Cj. Now what is Cj? Cj is known as the coefficients of objective functions. Now what is the coefficient of objective function? 3, 2, 0, 0. This is by default same throughout the question. Now what is basic variable? Basic variable means which you add the variables. Which variables we added? S1 and S2. So we write S1 and S2. Cost of basic variable. Initially the cost of the basic variables are 0, 0. What is the right hand side of the equation, which is known as xb? The right hand side of the equation is 4 and 2. What is x1, x2, s1 and s2? x1 is 1, x2 is 1, s1 is 1, s2 is 0. x1 is 1, x2 is minus 1. Here s1 is 0 and s2 is 1. Fine. So this is the table. You have to fill all the values in the table. Now the next is to find out ZJ. Now how to find ZJ? ZJ means CB into x1 plus CB into x1. So 0 into 1 plus 0 into 1, that is 0. In the first table, this ZJ is throughout 0. Like CB, that is 0 into 1 plus 0 into minus 1. That comes to 0. The next is CJ minus ZJ. So 3 minus 0 comes to 3. 2 minus 0, 2. 0 minus 0, 0. 0 minus 0, 0. Now, what is the condition to reach to the optimal solution is, in this maximization problem, the optimality condition is either Cj minus Zj all zeros or negative. So it can be 0, but there are two positive values, so it should be negative also. So all negative, all zeros, या zeros or negative. Now since we didn't reach to the optimal condition, so we have to create the another table. So how to create the another table? First of all, you have to check which is the maximum positive number in this. So this one is the maximum positive number. So this is the column in which we have a maximum positive number. So you have to mark this column, and this column is known as key column, right? Now what you have to do is to find the minimum ratio to check what is the key row. So xb, the right hand side, divided by the key column element, that is 4 divided by 1, that is 4. 2 divided by 1, that is 2. So which one is minimum? 2 is minimum. So you have to mark this particular row. Since this is the minimum ratio, so mark this particular row as key row. Now what is the intersection number in between the row and column? So 1 is the intersecting element, so which is known as key element. Fine. So this is the first table in which we come to know that this is known as the key column, the highest positive number. The minimum ratio, towards the minimum ratio, this one is the minimum row, and the intersecting element between the column and the row is known as key element. Now, since this is the key column, then the variable here is x1. In the minimum ratio, this particular row, this is known as, now in the next table, which one is the entering variable and which one is the leaving variable? S2. S2 is the leaving variable. S2 is the leaving variable, and here x1 is the entering variable. This one is known as the entering variable. So how we'll create the next table? Step 2. The by default, these are same. There's a basic variable, cost of basic variable, xb, x1, x2, s1, s2, and the minimum ratio, right? Now this time the basic variable means this one is the basic variable and this time this one is a leaving variable and x1 is the entering variable, so you will write here x1. Cost of the basic variable, again you know the cost of the basic variable of s1 is 0, and the cost of the basic variable of x1 you will check it from the objective function. यहाँ पर भी लिख सकते हैं उस objective function को, because this is throughout same. So s1 is 0 and the x1, the cost of the objective function, so x1 variable का cost कितना है 3, so you write it here 3. Now what the condition is to fill all the remaining values are, since you have to first check the minimum row is the second one, the intersecting element is 1, so there is a condition, the intersecting element should always be 1. By default here it is 1 only, but if it is for example 2, if it is 3, so what you have to do is, if it is for example 2, so you have to divide the whole row by 2 to make it 1. And the another condition is the above and below numbers are 0. Now how to check? Now xb, since by default this is the intersecting point is number is 1, so you just write down as it is 2, 1, minus 1, 0 and 1. Now to make it this number 0, how will we do? Can we subtract these two rows? If we subtract these two rows, the 1 minus 1 is 0. So if we are subtracting these two rows, 4 minus 2, 2. 1 minus 1, 0. 1 minus minus plus, that is 2. 1 minus 0 is 1 and 0 minus 1 is minus 1. Correct? Now again find ZJ. Find the method to find the ZJ is CB into this 0 into 0 plus 3 into 1. The first value comes to 3. 0 into 2 is 0 plus 3 into minus 1, that is minus 3. 0 into 1 and this is 0. This is 0 and this is 3. Now next is CJ minus ZJ. 3 minus 3, 0. 2 minus minus plus 3, 5. 0 minus 0 is 0. 0 minus 3 is 0. Again, you have to check whether you reach to the optimal condition or not. So here, 2 zeros and 1 negative number. But again, there are 1 positive. So what you have to do is you have to mark that positive, mark that particular column in which the positive number is there. Now find the minimum ratio. Now this time, this is your key column. Since the key column is in the front of x2, so this time x2 would be the entering variable. Now which one is the leaving variable? Now we'll check the minimum ratio. 2 divided by 2 is 1. 2 divided by minus 1. But since it is negative, so we'll not take the negative values. So by default, this is the minimum number 1. So this one is the minimum key row. So this one is the key row, this one is the key column and the intersecting. Now which one is the intersecting? Now here in this case 2 is the intersecting number. Now in the next table, how will we draw? Now in the next table, step 3, the format would be the same: basic variable, cost of basic variable, xb, x1, x2, s1, s2 and the minimum ratio. This is by default same CJ, that is 3, 2, 0, 0, right? Now how to, now this time in this particular question, this particular step, x1 by default same. Now here the key column is in the front of x2 and the key row is in the front of s1. So this time s1 is the leaving variable and x2 is the entering variable. So here we are writing x2 is the entering variable. Now what is the cost of x2? You will check the coefficient of x2. Here the coefficient of x2 is 2. So you will write here 2. Here the coefficient of x1, the objective function is, that is 3. Now xb, again, now these value, how will you calculate these value? These value depend on the previous step. Previous step is, since the key element is 2, so how will we have to first divide the particular row by 2 to make the intersecting element 1. So how will we? We divide the whole row by 2. In the next column, it is written 2, 1, minus 1, 0 and 1. To make it 0, because above and below element of the key element should be 0, so we make it 1 by dividing the whole row by 1. Now to make it 0, what we have to do is, can we add these two rows, this particular row and this particular row? Can we add these two? So 1 minus 1. It should be equal to 0. So the another method is, you can do like this, to make it rough. 0 1 sorry 1 0 1 1 by 2 minus 1 by 2, and the particular term is 2 1 minus 1 0 and 1. Now can we add these two, 2 and 3, 1 0 1 by 2 and 1 by 2? Write it here. 3 1 0 1 by 2 and 1 by 2. To make it 0, above and below numbers from the intersecting element should be 0, so we make it 0. Now again find ZJ. How to find ZJ? To find ZJ is CB, 2 into 0 plus 3 into 1, that is 3. 2 into 1 plus 3 into 0, 2. 2 into 1 by 2, that is 1, plus 3 into 1 by 2. 2 into 1 by 2 plus 3 into 1 by 2, that is 1 plus 3 by 2, that is 5 by 2. And in the next one, 2 into minus 1 by 2, that is minus 1 plus 3 by 2. So this is minus 1 by 2. Now the next is find Cj minus Zj. 3 minus 3, 0. 2 minus 2, 0. 0 minus 5 by 2, minus 5 by 2. 2 and 0, oh, so this is plus. 0 plus 1 by 2, 0 minus 1 by 2 is minus 1 by 2. Now we see the condition, all the values are 0 and negative. It means we reach to the optimal condition. It means since all the variables which we have to find, they come here, and all the slack variable which we added, they left from the basic variables. So the final values of x1 and x2 are, x1 is 3 and x2 is 1. So this is the values of the x1 and x2. Thank you.